Okay, so this is part 4. It says using Venn diagrams to decide if two sets are equal. What does equal mean? We learned this in lesson 1. In lesson 1, we said equal means whatever is in one set has to be exactly the same in the next set, but they don't have to be in the same order. But they have to be the same. Okay? So all elements in set A must be in set B. Or all elements in set B must be in set A. So all the elements in each set must be the same. It has to be equal. Equal in number, equal in elements. Okay? The order of the elements does not matter. So, order is not important. All you have to do is they must be the same. So I gave you an example. A and B. If we say A is equal to B, let's see. Do we have 1? Yes. Do we have 2? Yes. Do we have 3? Yes. Do we have 4? Yes. So all these elements are in here. So A and B are equal. Okay? So you'll be given sets. They'll tell you to draw and see if they're equal. So how do you determine from a drawing that you have equal sets? The picture must be the same. For you to be equal, the picture must look identical. So A union B complement. This is how you do it. That means whatever is in A and in B, you want what is not there. So what is not there is outside here, because you said complement. And then A complement means whatever is not in A. So that means this of B and outside. Okay? And whatever is not, B complement is whatever is not in B, which means this is A and the outside. So we have 2 colors where we'll have 2 colors outside. So that's where we want. We want where we have 2 colors. Because you have the color for B and the color for A. And the color for A and B will intersect outside here. Okay? So that is why we want the outside. Now this diagram is identical to this diagram. Therefore, they are equal. I wanted to show you with colors. We can do tomorrow in class. Remind me, we do this in class where we show 2 different colors and then we see where the 2 colors meet. That's how you see the answer to that. So if the shaded diagrams are identical, that means exactly the same. We use deductive reasoning to say that A union B complement is equal to A complement intersection B complement. Okay? So let's do another example. Decide if these 2 sets using Venn diagrams are equal. So you have A union B intersection C, and the other one is A intersection C union B intersection C. Okay? So maybe I don't know how to do it. So what do? My strategy is I make my own sets. This will help me. When I see my elements, it will tell me where I need to go, and quickly I'll be able to shade the correct region. Okay? So you have to make, so if you have 3 letters or 3 sets, you have to make 4. The 4th one is the universal set. Okay? So I made my universal set. I made my A, my B, and my C. How did I make? I said I'll choose some numbers in A and put here and some numbers there. Some numbers that are in both A, B, and C, and add more from the universal set. You make your own. Okay? This way it makes it easier. Alright. So then, now I do A union B. I need to take all of A and all of B without repeating. So I wrote my A, I wrote my B, and whatever I saw is in both, I crossed out. So I crossed out 2 and 4 because they were repeated. Okay? Do you see that? Oh, I forgot 5. There's a 5 over here. I need to cross it out. Okay? So, you write all that is in A. And then you come here, you skip the ones that you repeated, that's why you cross them. And the ones that you didn't repeat, you put them there. So this is A union B. Okay? Then after you do A union B, you now do the intersection of C. Whatever is here and is also in C. So I wrote my A union B and I wrote my C and I circled what is in both and I found 3, 5, 6, 9 is in both. So this is my answer for A union B intersection C, this. So where I see these numbers in the picture, I will color. So I come here and I draw my 3 circles. Using this information, I fill my Venn diagram. What number is only in A? 1. I wrote it over there. What number is in A and B? 2 and 4. Those are the only numbers that are in A and B. 2 and 4. What number is in B only? 8. What number is in B and C? 6 and 9. I wrote them there. 6 and 9. What number is in both A, B, and C? 5. I wrote it in the middle. What number is between A and C? 3. I wrote it over there. What number is in C only? 7, because I didn't circle it. See, the ones I didn't circle are the ones that are remaining. The number that is in all 3 sets, I put it in a rectangle or a square. Okay? And I used 3 different colors. See, I used red, I used my pencil, and then here I used my square to know. After I fill, because it says 3, 5, 6, 9, I color where I see 3, where I see 5, and where I see 6 and 9. So this is the picture I need to see in my answer. Okay, so now let us do this one. A intersection C union B intersection C. You have to use the same set that you used for the other one that you're trying to prove that is equal. You cannot change this. This has to be the same on both sides. Okay, so now we are doing the right side. This is our universal set, our A, our B, our C. A intersection C is what is in A and what is in B. Sorry, what is in A and also what is in C. So I wrote it like this. I wrote my A, I wrote my C, I circled. A intersection C is this. 3 and 5 are both in A and C. Then I did B intersection C. What numbers do I see in B what elements do I see in B that I also see in C? I found 6, 5, 8, and 9. Because I want to make the union, I need to use these without repeating. So what is repeated? 5. So I only write 5 one time. So this is my answer. Now using my picture, where do I see 3, 5, 6, 9? I colored. Now, if you compare my 2 diagrams, they look exactly the same. I forgot to put you. They look exactly the same. This picture is exactly the same as that picture. Okay? So then I write my statement. My diagrams are identical, and using deductive reasoning, I agree that A union B intersection C is equal to A intersection C union B intersection C. Okay? Let's do part 5, finding cardinality of a union. Cardinality means count how many elements are in that set. That's all cardinality means. Find the number of elements. So that means your answer is a number. Okay? So they gave us the sets. A is this, B is this, and they told us to find the cardinality of A, the cardinality of B, the cardinality of A intersection B, and the cardinality of A union B. We have to answer 4 different parts of this question. They also told us to draw a Venn diagram representing this information. Okay? So, finding the cardinality of A is easy. Count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Cardinality of A is 9. Cardinality of B is the same. Count. 1, 2, 3, 4, 5, 6, 7. Cardinality of B is 7. When you're writing cardinality, please make sure you write the N, the bracket, and put your set name inside the bracket. Alright. A intersection B, you must do before you count. A intersection B means what is both in A and B. What numbers are in A and what elements are in A and then also in B? 6, 7, 8, 9. So I wrote it here. Then I counted 1, 2, 3, 4. So I wrote the cardinality of A intersection B is 4. Okay? A union B is what is in A together with what is in B without repeating. I know I'm not going to repeat 6, 7, 8, 9 because it is both in A and B. So what was not written, I write 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I don't use these ones because I already used there. Then I write 10, 11, 12. Then I count all of them. 1, 2, 3, I should see I have 12 elements. So the cardinality of A union B is 12. Okay? Then we need to draw a Venn diagram. So if I draw my Venn diagram using this information that we have in the question, 1, 2, 3, 4, 5 will go to A only. A only. 6, 7, 8, 9 will go to where A and B cross each other. 10, 11, and 12 will go to B only. And here is my Venn diagram. Okay? So you know how to find the cardinality by using the set and by drawing. So if I was given the Venn diagram, A only, I count 1, 2, 3, 4, 5, 6, 7, 8, 9. Cardinality for A is the whole circle of A, which I have 9 elements. I got 9. Cardinality for B is the whole of B. The whole of B, which is 6, 1, 2, 3, 4, 5, 6, 7. There. Cardinality for A intersection B, I count 1, 2, 3, 4. There you go. Cardinality for A union B is everything. So you have 9 and then 10, 11, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, you only counted this once. You didn't go back again. No. Like that. Okay? So we need to use the formula.